So there are two terms that we use to describe our measurements, and those are accurate and precise. So accuracy has to do with how close to the true value something is, versus precision has to do with how close your data ratings are to each other. So when something is both accurate and precise, let's say you have 3 data points, they're going to be very close to each other and they're going to hit the target. So essentially they're going to be very close to the true value. When they're precise, they're going to be close to each other, but they're not hitting that target, meaning that they're not actually close to the true value. So these are precise but not accurate. And then here we have something that is both not accurate and precise, because it's neither hitting the target nor are these data values close to each other. So now we're changing gears again, and we are going to start looking at how we are going to be solving problems throughout this class. So a lot of the problems that we're going to solve are going to involve unit conversions. A unit equation specifically is something like this. So you will have a statement where you have two equivalent quantities that equal to each other. So either they have, most likely these have been measured by like scientists, and it's been established that these two things equal to each other. Here are some more examples. A lot of these examples are converting like from metric to imperial measurements, so American measurements, and these are ones that you will be using frequently. Now, for exams, let's say I ask you to convert from yards to meters, and quizzes also. Let's say I ask you to do that. You don't have to know those unit conversion, you don't have to know that unit equation. I will give it to you. My whole thing is that you have to know how to use it. So that's what we're going to do next. So this is how we are going to go about using our conversion factors to get from one type of unit to a different one. So you will be given a certain value with a certain unit, right? So basically this is the information you're given in your problem. You're going to use your conversion factor to get the information that you're looking for. So in the very last part of the problem, it'll have a question and it'll ask for something. This is what you're calculating for. So the way that you're going to set it up is that you will have a unit, you'll have a conversion factor that has your desired unit and your given unit, and it helps you convert essentially to what you want. Now, this is how you set it up. So your given has to be at the bottom in order for it to cancel out with your original information that you're given. So what we just talked about is actually something called dimensional analysis. I know it sounds like fancy and it sounds difficult, but all this is the fact that we're using a conversion factor in order to get information that we want. And this is a process called dimensional analysis. So now we're going to start with this example. This example is kind of funny because it doesn't really make any sense. These things aren't real things, but the point is that you will see that you can do dimensional analysis with any unit conversion factors that you have. So this question is asking how many ploufs are there in 22 Pliggles, and they give us 3 separate conversion factors here. So we know that we're starting off with Pliggles, right? You always start off with what you are given in your problem, and then you see where you can go from there. So in order to see where we need to go next, you look for whatever unit conversion factor has something in common with what you're given. And the one that has something in common is this one right here. 5 Pliggles equals 7 camis. Now, if you go back to the slide, the previous slide, and just refresh yourself on how we set this up, we're going to put the unit that we want to get out of the way. So the Pliggles, we want to convert from that to whatever we can next at the bottom. And then your other unit, your desired unit, will go on top. Now we have Pliggles canceled out and we're at camis. Camis is not what we, not ploufs, so we're still not done yet. And we look at the unit conversion factors and we find that this one is the one that has camis. So we know that we have to use that one next. And we're trying to get rid of camis, right? So it goes at the bottom. So 1 cami equals 3 cax. Okay, cool. We got camis out of the way. Now we're at cax. Is that the final answer? No, we need to go to ploufs. So we find that this last conversion factor actually has both of those. So now we're finally at our last step. So in order to cancel cax out, we're going to put that at the bottom. And you always put that value that's in front of it with it. And then our 9 ploufs will go at the top. So our CACs cancel out, and finally we get our final answer. So whenever you calculate this out, you will end up getting PLOOFs as your unit. So because we are multiplying and dividing for these problems, or this problem specifically, through dimensional analysis, we know that our final answer will be whatever has the least number of sig figs. And the least number of sig figs is here, 1, 1, and 1. So we know that we only want 1 sig fig in this case. Because we only want 1 sig fig, and this value is essentially the lowest, like you can round it to, is 55. We are going to have to convert this to scientific notation, and when we convert it and round at the end, we end up getting 6 times 10 to the 1. PLOOFs. So now we're going to practice converting between different prefix multipliers. So in both of these cases, we have the same unit. It's just the fact that there is a different prefix multiplier. So on this first example, we are going from milligrams to grams. So our known is our 1,340 milligrams, and we are trying to get to grams. So the conversion unit factor that we are using is this one right here. 1 milligrams equals 1 times 10 to the negative third grams. I got that from this table. So here you can see an example, and here is the factor that you will be using. So to set this up, I'm going to put my 1 milligram at the bottom, and then that's what we want to cancel out, and then I'm going to put my gram factor at the top. When you multiply this out, you end up getting 1.340 grams. Now, in terms of sig figs, this is going from one metric unit to another. The only thing that's changing is the multiplier, so that means that our conversion factor right here has an unlimited number of sig figs. It's an exact number, so we do not take that into account when we consider how many sig figs our final answer will be. So all we do is look at how many sig figs our original information gives us, and that's 4, so that means our final answer will have 4 sig figs. Now it's a very similar case here, so our information given has 3 sig figs, so our final answer will have 3 sig figs, and then we kind of go through the same process. This time our liters will be at the bottom, so I'm just taking that conversion factor and setting it up. Liters cancels out, and then we put that 1 ml, which is our desired unit, at the top. And when you multiply this out, what you end up getting is 567 milliliters, and that's going to stay as 3 sig figs because of the same reason earlier. So we're going to go through a few more examples pretty quickly right here. I have almost everything set up. I'm just going to go through the answers and determining sig figs with you. So this first question is asking how many centimeters are there in 34 inches? So your unknown is centimeters, and your known is that we have 34 inches. We're given our conversion factor right here. This is an exact conversion factor because it's going from metric to, whichever way, American to metric units. So this is an exact number, meaning you don't take that into account for sig figs. Now, what we're given is a value with 2 sig figs, so that means our final answer will have 2 sig figs. So you write out what you're given, and then you set it up so that your unit cancels out. So we have our inches cancel out, and then we have our centimeters being our desired unit. We end up getting 86.36 centimeters. Now we only want 2 sig figs, so that means we have to round out. So to round out, we look at that 3 right there. Because that's less than 5, then we round down. We stay at the number we're at, so we round down, and our final answer is 86 centimeters. Now this next one is having to do with time. So most people are recommended to sleep 8 hours. How many seconds is that? Our conversion factor is 1 hour equals 3,600 seconds. This is an exact number as well. I know I didn't list it on the 3 bullet points on that previous slide, but just consider time and conversions between time also in exact numbers. So when we set this up, we start off with 8 hours, that's our known, and then our unknown is how many seconds that is. So we set it up to cancel out our hours, and then we end up getting, when we multiply this out, we end up getting 288 28,800 seconds. Now, this is not 1 sig fig the way that the final answer should be. So what we end up having to do is first convert this to scientific notation. So when we convert it, we should get something that looks like this. And we had to move over that decimal point 1, 2, 3, and 4 times. So this should be 10 to the 4th since we moved it to the left. Now this is still not 1 sig fig, so what we have to do is look at this number right here and round. So we end up getting 3 times 10 to the 4th because that number is bigger than 5, so our final answer is 3 times, I know that looks kind of weird, let me write it over, 3 times 10 to the 4th seconds. Now this final example is pretty straightforward, similar to the previous ones. Again, this is an exact conversion factor because it's going from one American unit to another American unit. So we start off with inches, we set it up so that inches is at the bottom and it cancels that original inches out, and then we end up getting yards as our desired unit. Now again, what we're given is only 2 sig figs, so that means our final answer should be 2 sig figs, so that's what I wrote right here.